Hello, advanced algebra students, and welcome back to another video lesson as we continue exploring functions and looking at quadratics and different things of that nature. Today we are going to focus and begin something called inverses of functions. Trying to use graphs to identify whether or not we can have an inverse and explain why something is an inverse or not using this horizontal line test. Now, here's the heads up for this week. Again, a lot of inverse here for the rest of these 3 days, Monday, Tuesday, Wednesday. Today's the intro, kind of, and then we start to find the inverses of an equation and prove two equations are inverses of each other or not. A review day on Thursday so that we can do a mini test on Friday. Again, no calc on the mini test, and so all of this week's activities and practices will help you prepare. First, a warm-up from what we were doing last week, compositions. You've got three equations up there, or functions. Evaluate the following: f of g of h of 1. This means we're looking for h of 1 first. So h of 1 is going to be equal to 2 times 1 to the third. 1 to the third is 1, and 2 times 1 is 2. So now we have f of g of 2, because we found that h of 1 to give us a value of 2. So the g of 2, right, g of 2 is equal to 12 divided by 2, which is 6. Which means we are going to look for the f of 6. And if we use the f function, the f of 6 will equal 4 times 6 plus 5. Following the order of operations, we get 24 plus 5, which is 29. So this whole thing right up here, f of g of h of 1 will equal 29. All right, starting with the inside and working our way out. Now, here's my question to you. What do you remember about functions, and do you recognize any of these? Which of these are functions? Well, 1, 2, 3, 4. 1, 2, and 4 are functions because they pass that vertical line test. If I were to draw a vertical line, these imaginary vertical lines, it would never go through the graph twice. Same thing here. If they were straight vertical lines, I'm going a little quick. Whereas number 3, it doesn't, right? One vertical line is going to hit the graph twice. So that vertical line test is one way to help us figure out if these are functions. This is the function y equals absolute value of x. This is a y equals negative x squared function of some sort because it opened down. We don't know this one quite yet. And then this is an odd powered, if we remember back to our odd. So we're doing a lot of work with functions today and trying to find their inverse, okay? Their inverse. And so a function, when we worked with functions, for each input, there was exactly one output. Or another way to say it, for every x, there is only one y. Or we can ask, does x repeat itself? And so we looked at these a lot of different ways. We had tables and ordered pairs, where this set right here is a function because none of the x values repeat, where this second set are not a function because I've got 4, 4, right? Meaning the 4 would go to 12 and the 4 would go to 15. So the input or the x value repeats. And that's why we can use the vertical line test as well, because a vertical line is the equation x equals. And if it ever touches twice, this would be like the point 2 comma 5, and this would be the point 2 comma negative 5. And the x values repeated. So that's why we use that vertical line test. All right, so here's what I want you to do very quickly. I'll go A, B, and C. Tell me if it is a function or not. Letter A, not a function. It's not. You have a coordinate 1, 5, and you have a coordinate 1, 7. You have two x values coming out of the domain. Letter B. Yes, it is a function. Why? Well, I don't have any inputs that repeat. None of the inputs repeat. Letter C. I try and look for a vertical line. We're good there, so yes, it passes the vertical line test. Okay, and so that's what you're looking at for functions when we were dealing with them in the past. However, today we're going to be looking at what is called the inverse. And the inverse of a function or even a relationship is obtained by switching the coordinates. We switch the coordinates. Okay, so if my function here is x of y, x comma y, the inverse function means we're going to switch the order of those and have y comma x. A little bit confusing at first, but we're basically just switching the order, okay? And these are the way that we have the notation. F of x is the regular function. F to the -1, that's that inverse. Remember, we used this in trigonometry a little bit where we did those tan inverses or sine inverses to help us solve. Now, here's an example underneath this box. Why don't you see if you can't find the inverse of this function? See what you think you know for finding the inverse. So the inverse is simply, and I don't want to say simply because it's not just easy, but what we're going to do is switch the order. The first one becomes 5, -2. The second one becomes 7, -1. The third one becomes 3, 0. Got to switch those around. And then we've got 7, 1. And then we've got 1, 2. Right? Just switching the x and y order, that's all. That's what the inverse does. Now I can look at the inverse and try and figure out if that is a function. Do any of these x values repeat? And it's not a function because there are 2, 7 for x values. 7 goes to -1 and 7 goes to +1. So it would not be a function. But that's what we're going to focus a lot on, okay? And we're going to have a bunch of examples that will help us get there. Now, you can perform what's called a horizontal line test to tell whether or not the inverse will be a function. Okay, so imagine for a moment the red line isn't there, okay? Y equals the regular function h of x, this blue line. That's a function because the blue passes the vertical line test. But if I run a horizontal line test on this function, the red line, notice that at like this spot, or even if I did another, maybe a red line up or down, even if I tried to do it up here or down here, right, that blue function would not pass. And what that means is if I were to flip all of the x and y coordinates, I'm going to get this blue line now, and the inverse would not pass the vertical line test. The inverse wouldn't, which means the inverse is not a function. So we can tell it by doing a vertical line test on inverse or doing a horizontal line test on the regular function. All right, so here's some examples. Let's take a look at some of them that we've worked with in the past, the odd function. All right, determine if the whoa, sorry, I don't want to go that way. What happened? Here we go. Determine if the inverse is a function. So if we want to know just quickly by looking at it, we would do a horizontal line test. And most of these blue or these red lines are not going to touch that blue graph more than once. So I'm going to get rid of them now. We can say yes. It passes the HLT. It passes that horizontal line test. Passes the HLT, horizontal line test. All right, so now let's determine the domain and the range of the original function. Domain goes with the x. So if we look at the x values, it's going to keep going left as far as it wants and right. So the domain of that function is all real numbers, and the range is also all real numbers, because it's going to go up and down as far as it wants. So the domain and range of the original function is all real numbers. Now graph the inverse on the same graph to check the function. And so what we do is we got to grab a couple different points. Like here's a point on the graph. Maybe we'll try this one. Looks like we can do this one. And we can do that one. And what we've got to do is switch the ordered pair. Okay. Well, this is 1, 1. So if we switch it, it's going to stay at 1, 1. That's the nice part. This is at 1.5, comma 4. So we'd have to do 4, 1, 2, 3, 4, and 1.5. So like right there, if I switch those around, and this one is negative 1.5, negative 4, negative 1.5 with negative 4. And so what we need to do is switch them around and go negative 4, negative 1.5. And so the inverse graph would look something like that red line. So find yourself, 3 to 5 points that you can replot to graph, and notice that red line would pass the vertical line test. What is the domain and range of the inverse, that red line? Well, guess what? The domain is also all real numbers for that inverse, and the range is also all real numbers for the inverse. Because it's going to go left and right as far as it wants, and up and down slowly as far as it wants. Okay, so that's what we're looking at for today. Now here's a nice hint. For inverses, the domain and the range are just going to flip, because we're just changing the x and the y anyway, right? The domain and the range, for the inverse, they would flip. But that's because we just switched the x and the y. Let's try another one. Here's an example of another type of graph. Is the inverse a function? No, definitely not going to be. It fails that HLT. It fails that horizontal line test. Okay, we could draw a line right there to say, yep, it fails. All right, what's the domain? The domain of that function as we see it, it's going to go left as far as it wants. It's going to go right as far as it wants. So the domain will be all real numbers. And the range, well, we got to check where it is on the y. It doesn't go above this on the y, but everything continues to go down. So the range, we say y is less than or equal to 2. Y is less than or equal to 2, because it's all going to go underneath. All right, now we need to change the graph. We need to switch it up to show the inverse. And we've got some points, right? -2, -2. Well, that's going to stay there. 2, 2. Well, that's going to stay there. How about 5, 2? 5, 2. If we switch it, that's going to be 2, 5. 1, 2, 1, 2, 3, 4, 5. So right there. If we look at this one, it's 9, -2. 9 with -2. So we've got to go -2 and up 9, which is like off our graph. Oh no. Right? And so our graph ends up looking like this. Weird looking graph, but there it is. What's the domain? Well, the domain in this case, instead of y being, let me get this, be a D. Domain, instead of y being less than or equal to 2, we just switch it to x is less than or equal to 2. Right? This becomes the domain. We just have to make sure the domain goes with x, and the range is whatever the domain for the original function was, which is all real numbers. Okay, so they just kind of switch. Now here's the last one. All right, consider this function, y equals -2x squared with its domain. The domain is all real numbers, right? So, hey, look at that, the domain, all real. Graph this function. So 1 point. If I plug in a 0 for x, I'm going to get out a 0 for y, which would be right here. If I plug in a 1 for x, I'm going to get -2, right? And I'm plugging them into this function up here. So 1, -2. If I plug in -1, I'm also going to get -2. So -1, -2, and so on, okay? The graph will just keep going in that nature. All right. Is the inverse a function? Is the inverse going to be a function? No. Again, this fails the horizontal line test. Fails the HLT. Okay. Domain and range of the original function. Well, the range has to be y is less than or equal to 0. What are the domain and range of the inverse? Well, we switched them. The domain is going to be x is less than or equal to 0, and the range will be all real numbers. What is the equation for this inverse function? Now, that's something we haven't talked about yet, but we're going to just introduce it for today. Remember, we're switching the x and the y to help us maybe graph the inverse or identify where it might be located. And so if I'm going to switch the x and the y in the ordered pairs, I'm going to take this equation and just switch the x and the y. X equals -2y squared. And what we're going to learn from there is how to solve from y in the next couple of days. So this is the beginning to inverses. Please make sure you reach out if you have any questions as we continue to build off of it. Otherwise, until next time, everyone, stay safe.